Hello, geometry students, Mr. Fugay. Today we're going to talk about the unit circle, and then in addition, we're going to introduce the special angles in trigonometry. So to prepare for this video so that you can follow along and try some of the things I'm doing in the video, be sure to have this page open for your notes. It's called Notes, the Unit Circle. And then in addition, this interactive unit circle, I'd like you to click on that, and when you do, it's going to open up a picture that looks just like this. We're going to be referring to this a few times throughout the video. So let's head back to OneNote and get started. So we're going to first mention something called the unit circle. A unit circle specifically is a circle with a radius of 1, hence the name unit circle, singular. And the unit circle is centered at the origin. Now, algebraically, we learned this in Algebra 2 as the equation x squared plus y squared equals 1. Now, there's a reason why we're talking about the unit circle. So one, it's going to allow us to look at all of the angles in standard position in cohesion. As I drag this point around the outside of the circle, it's going to create all possibilities for angles between 0 and 360, or if we do radians, 0 and 2 pi. So as I slide this dot around, I can drop my vertical line, connect my terminal side, and we have our right triangle. Now, all of these numbers are auto-calculated. We're going to talk about how that is in just a second. But notice the common thread here is that the hypotenuse, which we also now call the R value, is always going to be 1 no matter what. So because of that, this actually simplifies our trig ratios when we work with the unit circle. Rather than remembering that sine is y over r, in the unit circle, the sine is actually just the y value. And cosine is no longer x over r. Well, it still is, but since r is 1, that's just going to make cosine equal to just x. Now, what this actually does is something interesting for tangent, because tangent we learned as the ratio y over x, but since we just got done saying that sine is equal to y, cosine is equal to x, a new way to define tangent is actually the ratio sine over cosine. Still y over x, but now we're using these unit circle definitions. Now, why is this so powerful? Well, if we look at our interactive unit circle, if I go to, let's say, 50 degrees, okay, that's close enough, you'll notice that the sine ratio, which is opposite over hypotenuse, or y over r, is 0.78 over 1, and look what the y value is. I messed it up as I did that. 0.7, it was 7.1, but now it's 7.7. Same idea, that this value right here and this value right here is exactly what sine of 50.3 is. So let's actually look at that real quickly on a calculator, because if we go to Desmo's scientific calculator, or if we pull out your own scientific calculator, if we ask for sine of 50.3, it returns an answer of 0.769, which is exactly what the y coordinate is. Likewise, if I want to find cosine of 50.3, it says it's 0.638. That is the x value. So where you put this black point to create your triangle in standard position, the x value is always going to be your cosine, and the y value is always going to be your sine. So let's see how we can use this unit circle to find these ratios. So we, of course, could type all of these in our calculators and get the answer, but we can now use the unit circle to help us with this as well. So sine of 42 is just going to equal the y value when I've placed my triangle in the 42-degree position. So let's go ahead and go to 42 degrees, and I'll get as close as I can. If you're off by less than a tenth, then you're probably fine. They're 42.05. Now I was asking for sine. Sine is the y coordinate, so sine of 42 is equal to 0.67. So sine of 42, we'll erase the y there and write it at 0.67. Now this will work for other angles as well. So let's look at 233 degrees. So if I take and move my point so that my angle is 233, let's go ahead and get there. It's quadrant 3 actually, so let's keep going. 233 is going to put me right about there. And we are being asked to find cosine this time. Cosine is going to be my x value, and you should see that the x value here is negative 0.6. So that's what I'm going to go ahead and write down here is negative 0.6. Notice that that will line up with the fact that we know cosine is supposed to be negative in quadrant 3, so that still lines up. Now, if we have tangent of 392, since this is above 360, and we are going to rotate this. When I rotate around and get to 360, it resets to 0. And the reason why it does that is because we're going to look at its coterminal angle between 0 and 360 instead. So 392 is the exact same thing as tangent of 32 degrees, since 392 minus 360 is 32. So let's go and get a 32-degree angle on our unit circle. So if I go to 32, that is going to be right about, we'll leave it there. And in this case, it's asking us to find tangent. Now this one we got to be careful with because it can't just pull one of these numbers. Tangent, as we mentioned, is y over x. So it's 0.53 over 0.85. 0.53 over 0.85. Now, if we don't have a calculator, we're just going to leave it like this. But in the calculator, if I do 0.53 divided by 0.85, that actually gives me a decimal of 0.62. All right, let's look at one more, and then we'll have you pause and try some of this. So secant of 125 degrees. So if I go to 125, and we'll go just a little short of that, 125, they're asking us to find secant. Now, secant is the reciprocal of cosine, so this is really just 1 over cosine of 125. Since cosine is going to be my x value, let's go find that x value. My x value is negative 0.58. So that's going to be my answer, 1 over negative 0.58. Of course, you can simplify that if you want. All of these answers would work exactly the same as if you typed it into your calculator. Now, I'd like you to go ahead and pause this video and try letters E through H. All right, well, here are our answers for E through H. Notice that E and G both came out as 0.67. One was positive, one was negative, which is also what we got for letter A. I'm going to highlight those three answers because I want to come back to this in just a moment in the video. So let's highlight those for now and just remind ourselves of those. And then another thing I want to also mention here to highlight is letters B and H, because they also gave us the same ratio, cosine of 127 and cosine of 233. We'll come back to that in just a moment. Now, there's one more thing I want to try to do with our unit circle, and that is to find some missing points and also angles here. So in this example, it says the point negative 0.4 comma y, which means you don't know the y coordinate, lies in the unit circle, and specifically it lies in quadrant 2. We want to figure out what that y value is and what that theta value is so that we can then figure out cosine of theta. So how are we going to do that? Let's go back to our interactive unit circle. We know that we need the x coordinate to be negative 0.4, and we know it needs to be in quadrant 2. So let's go ahead and back this up to negative 0.4, and there it is, negative 0.4. Notice that the y value is 0.91, and our angle is 113.85. So let's go ahead and write those down. So 0.91 is my y value, and my theta value here is going to be 113.85. Now, with this being said, we can now find our cosine. Cosine of theta, as we mentioned, is just now x on the unit circle. And actually, we already had that from the beginning of the problem. Cosine of 113.85 is just going to equal negative 0.4. So go ahead and take this and try letters B, C, and D. Let's see how you do. Welcome back. Here are the answers for B, C, and D, and I've also provided on the right-hand side a screenshot of what the picture should look like and where I got my values from. Now, there's one last thing we're going to talk about in this video, and that is some special angles. Now, I want to go back to example 1 and give you a chance to look at the fact that sine of 42, sine of 138, and sine of 318 all gave me 0.67. In letter G, the answer was negative, but besides the fact of that, they are all the same answers. Why is this happening? It has everything to do with the fact that trig ratios that have the same reference angle will have the same value, but they may have a different sign. So let's explain what we mean by that. So the sine of 42 degrees, if I draw it in standard position, is going to look something like that. Now notice where that is at. Sine of 42, of course, is going to be equal to y. So the y coordinate right here, as we figured out, is 0.67. Now in quadrant 2, what would be an angle that would have the same reference angle? Well, we're going to take 180 minus 42. So sine of 138, that angle is going to look like this. And when I draw that in, you'll notice that it has the same y value. The point is at the same height on the unit circle. So that is the reason for both of these why the answer is 0.67 and why the answer for this is also 0.67. But when we move down into quadrant 3, the reference angle that has 42 degrees in quadrant 3 would be 180 plus 42. So that would be sine of 222. Now that's going to be located right down here. And where that's going to be on the y-axis is at negative 0.67. That's going to be my angle in quadrant 3. And last but not least, this is going to be negative 0.67. And then finally, in quadrant number 4, the reference angle is going to be 360 minus 42, or 318 degrees. If we draw this angle, it's going to look like this. Notice that that has the same y value as well. So that's the reason why sine is negative in those two quadrants, but ultimately all the answers are 0.67. So what does this mean for us? Well, we're going to move back to our special right triangles that we learned earlier in the course. Our special right triangles for the 30, 60, 90 are 1, 2, square root of 3. And for 45, 45, 90, it's 1, 1, square root of 2. Now, we also defined it on the unit circle that if you make the hypotenuse equal to 1, it changes the values a little bit. It's going to make this equal to 1/2, make this equal to root 3 over 2. If the hypotenuse here is going to be 1, it's going to make the legs 1 over root 2 and 1 over root 2. And those are found by using proportions and similar triangles. So if we go back to our original sine, cosine, and tangent for, let's say, 30 degrees, let's write a few things in. In radians, this is going to be pi over 6. And reference angles in quadrant 1 are the same as the radian measure, so pi over 6 also. Sine of 30 is going to be opposite over adjacent. So that's going to be, opposite over hypotenuse. It's going to be 1 over 2. So my 30-degree angle is located right there. So sine is going to be equal to 1/2, which, by the way, equals the x value, or the y value there. Cosine is going to be adjacent over hypotenuse, so this is going to be root 3 over 2. And finally, tangent is going to be 1 over the square root of 3. Now, what happens with this is that this is going to get replicated with other angles that have a reference of pi over 6 or 30 degrees. That would be 150 degrees, which happens to be 5 pi over 6, so reference of pi over 6. 210, which is 7 pi over 6, or pi over 6. And finally, 330 degrees, which is 11 pi over 6, which also has a reference of pi over 6. So what happens is in all of those other places, we're going to end up with 1/2, root 3 over 2, 1 over root 3. And we're just going to copy these down because they're going to have the exact same ratios, just like I showed you with sine of 42, sine of 222, and those other two angles. The only difference is that we are going to have to look at the signs, positive, negative signs of these answers using All Students Take Calculus. Quadrant 2, sine will remain positive, but cosine and tangent will turn negative. In quadrant 3, tangent is going to remain positive, but sine and cosine will turn negative. And finally, in quadrant 4, cosine will remain positive, but sine and tangent will remain negative. So your challenge for the remainder of this is to pause. Well, the video is going to end. And what I want you to do is to fill out the triangles and the ratios for 45 and 60, and then their reference angles counterparts in quadrants 2, 3, and 4. So all of the ones in blue and all of the ones in pink/red. That's your challenge. Try it out and check in with me when you're done. Thanks for watching.